All right, let's go ahead and get started. Hi, everybody. How are you all doing today? You doing all right? Just okay? I have some bad news today, and I hope it's not something that's a crisis, but I want you to remain calm for this. I forgot my bag of candy. Are you all right? So I don't have my bag of candy. You're going to have to get by without it today. I will try and give out twice as much candy next time. All right, if you remind me. Pardon? Yeah, I know, and I don't have the code is right today because we have a bunch of stuff to get through, and I want to spend more time getting you ready for the exam than that. So last time, what did we talk about? Vectors. What is a vector? A container that holds many variables of the same type. Actually, exactly. And then we did a bunch of exam prep. We talked over how to solve problems. Remember, I showed you line numbering and doing all the things. We'll do another one of those today. And that was good for you, I'm sure. All right. So the new project was posted. Did you all take a look at it? Anybody happen to see it was posted? How does it look? Different? Yeah, you're going to learn some new things. And one of the reasons we're not going to do fun stuff today, though I wish I had the candy, is because we're going to work on some things about the new project. Now, anybody notice something different about this project than the last ones? There is no algorithm due, right? The first two we had you do an algorithm. This time we didn't. Why not? I know, I had to look ahead at my slides because I couldn't remember where that one appeared, but it's a trap. Just because there's no algorithm due, does that mean that you should not do one? No. Just because there's no algorithm due, does this mean you should not start on this until March 23rd? No. What's going to happen if you wait that long? You're going to have a bad day, okay? If you wait that long, it's going to be bad. So you need to start working on it ahead of time. I know that right now the exam midterm probably looms larger in your collective vision, but it's still important for you to start working on the project, okay? All right. Any questions about anything before we get started? Oh, one other thing I should mention, I also posted a bunch of midterm study material on Facebook, so you probably noticed that. Anybody not get a chance to see Blackboard? Facebook and Blackboard. I'm old. All social media is the same. So, all right. But you all got a chance to look at that? Yes? No? You should. Okay. Any questions based on that? Going once? Going twice? Yes? Uh-huh. So the question was what is up to? Yes. It'll be on stuff we covered today and maybe a little bit on Tuesday, depending on how far we get today. That being said, I'm not going to come up with the hardest possible question I ever could have on the most recent material and expect you to magically know that without having worked with it. But I will expect you to do some of the stuff. And I do have practice problems we're doing in class that will be similar to what would show up on the exam. So, other questions? And on Tuesday, I'll make it a little clearer about, oh, wait a minute. Oh, yeah, you have to take it early. Oh, yeah, I forgot that you had to take it early. Okay, yeah, and one thing I forgot is there's some material out of Chapter 5. I haven't posted the readings from Chapter 5 from the textbook yet. If somebody is in front of a computer and has email, if you'll email me right now, I will remember to do that later. If you don't, then I may or may not remember. So, okay. All right. So last time, one of the things we did was we were looking at this program. Do you remember this one? And we had a vector, and what we were doing is two things. First, we were filling this vector up with lists of mammals that came out of a file, right? And the next thing that we were doing was searching through the list of animals that we loaded in to see if there was one that you wanted to see a fuzzy little one of, right? Do you remember that? So our algorithm essentially, from a high level, consisted of two things. Loading a file into a vector, searching through that vector to see if there was anything interesting there. Does that make sense? Everybody with me? Now, wouldn't it be nice for us if we were able to actually write code like that? Right? If we were able to say, load a bunch of animals from a vector, and give it a command, say load all the animals from the vector, and then search the vector for what we're interested in. How many of y'all think that would be a lot better than actually having to write every single line independently? Better? How many of you like the attention to detail and micromanaging the computer? Nobody? Okay. Well, we still have to micromanage the computer, but we can make it so that we can break down our algorithm and make it easier. So here's what I'm going to do. I'm going to create a new file here, and we're going to call it, sorry, just one second. Just for organizational purposes, I have to go create the correct directory. Okay. Okay, so here's what I'm going to do. I've created this file, mammals2.cc, which will be in the appropriate place. And what I'm going to do is I'm going to stop it. I hate when that happens. All right. Okay, so what I'm going to do is I want to rewrite our program to make it pretty simple. We're going to have a bunch of mammals, and what I really want to do is just have two commands. And ideally it would be something like this. We would say load some mammals from the vector. Search for mammals. How many of y'all like that better than that last bunch of stuff we had? Is that nice? All right, here's what we're going to start talking about. We're going to start talking about how to do exactly this. One of the ways I like to think about this is that in C++, C++ comes with certain words and certain commands that you can use to manipulate things. What we're essentially doing is writing our own commands. We will be able to write our own commands that do what we want it to do so that we can build algorithms from a pretty high level and worry about the details some other time. All right, everybody with me with this? Do you remember back on the first day of class when we talked about flowcharts? Maybe that was the second day of class we talked about flowcharts. I said there were several things we're going to learn. We're going to learn how to do statements. We're going to learn input and output. We're going to learn decisions, right? And we're going to learn loops. There was one other thing that we talked about that day. Anybody remember what it was? Yes? Sub-algorithms or functions. And this is exactly what we're doing now. In what we're doing now, we're going to build things called functions. And the idea of these functions is that we're able to, from a relatively high level, split our overall algorithm into small parts. And if we can build each of these small parts of our algorithm correctly, then what we end up having is at the top level, we do something that looks like this, right? Load mammals from vector, or from file, I should say, and then search for mammals. And this makes things a lot easier conceptually. Okay? Everybody with me? Sir? Nope. Nope. We'll get there. Trust me. All right. But everybody with me right now. So the idea right now is instead of having an algorithm worrying about all the steps, we can break it down into pieces and then write each of these pieces separately. And doing so is like building commands in C++ that we can call and use ourselves that solve our problem. Okay? All right. So let's just start talking about functions briefly, and I'll show you an example of functions, and what we'll do after we've done some other work about functions is we'll come back and finish this up. Now, we may not even get to this class, it may be next class, but we will come back to this as an example. And it turns out the reason I'm using this as an example is it's very similar to what you have to do on Project 3, right, where you're working with vectors of strings and things that you're loading out of a file. All right, so let's create a new file. All right, so what does this program do? Start and stop. It's our basic program. Now let's talk about doing some other things in here. And I'll just show you how we can do that. Let's say that we wanted to, what function should we do first? Let's say that we wanted to multiply something by 2, okay? We wanted to have our own command, a very simple command, that will multiply whatever we give it by 2. Everybody with me on that? So you remember math, the math library, we use ceiling, we use floor, there's like square root and other stuff in there. Each one of these is a function, and what we want to do is write our own function that doubles the value of something. Okay? Everybody with me on that? So here's what we do. We have to define a function to do so. And when we define functions, we have to put something at the top that is called the function prototype. And the function prototype shows what our function is going to look like. The function prototype has 3 different parts. The first part is what's called the return value. The second part is the identifier, which is the name. And the third thing is a bunch of parameters. Parameters. Okay? The third part is the parameters. And so here's one way to think about this. When we have a sub-algorithm, it's going to do some work for us. It's going to work on data, and it's going to give some data back, right? So if I wanted you to multiply something by 2, who wants to be my multiply by 2 function? Anybody? All of you candy next week? Oh, yes, sir. All right. I'm going to give you a number, and you're going to multiply 2 and give it back. Ready? 6. So he said 12, which is correct. It seems to work in this case, right? There are 3 parts to this function. There is the input, which I am giving him, which is 6. There is the actual operation of the function, which is doubling something. And then there is the output, which is 12. You can think of the parameters as the input. The parameters are the input to the function. Okay. You can think of the return value as the output of the function, what it gives back. So I gave him 6, that would be the parameter. He doubled it, and he returned 12. So let's actually write this function now. So, I'm sorry, I made a mistake here. When I said return value, I should have said return type. What is actually going to be returned back, the type, not the value, because the value varies. So when we want to say doubled, we say int doubled int. And in the function prototype, what this says is that we have this function. Its name is doubled. It takes an integer as a parameter. The other way we say this is it takes an integer as an argument, but this is the input that we are handing to our sub-algorithm. And when we're done, when this thing's done, it's going to give us an integer back. Okay? Everybody with me on that? So we have a return type, in this case it's integer, an identifier, which is the name, and some parameters. This is just the prototype. Now for the purposes of this class, we will put the function prototype before main. Before main. And just like we have a function prototype, we also have to have a function definition, which is the real full code of what is supposed to happen and what is supposed to work. Now you might ask yourself, why? You might ask me, why? Why, Clay, do we have a prototype and then a definition later? Does anybody want to ask me that? No? Nope, it's in the correct place. Okay? Anybody want to ask me why we have a prototype and a separate thing? No? I'll just go on then. Oh, now someone wants to know why? Okay, well here's why. What's going to happen is when we use this in our main or anywhere else, we say int x equals 2, right? And then we say int y, and we'll just set it equals 0, and now we say y equals doubled x, like this. What happens is when the compiler compiles this, it starts at the top and it goes, okay, I need IOStream, I need using namespace standard. It looks and it goes, oh, int doubled int. This is just a warning to the compiler saying, hey, later when you see something named doubled that has an integer as a parameter, don't freak out. Don't worry about it. It's going to show up later. And the compiler goes, okay, I'll remember that for later. And it reads on, it goes int main, and it goes, oh, whoa, doubled. Where have I seen this before? And it goes, oh, I saw it before up ahead, and x is an int, so the name matches and the int parameter type matches. So now I'm not going to freak out. And then later it keeps reading on, and after main and its own little definition below, it says, oh, here is the full definition of what I am supposed to do. Okay. So the prototype exists as a warning to the compiler so that as it reads through your code, it knows that this thing exists, and it won't worry about it when it sees it elsewhere. The function prototype has 3 parts: return type, an identifier, and a parameter list. The parameter list is the input. The return type is the output of that subalgorithm. All right. Everybody good so far? Who's good? Who wants me to go on and talk more detail about something else? All right. So up here, this prototype doesn't say how the function works, does it? It just says its name. Down here in the definition, we have to say how it works. So one of the things about these function definitions is that when you give it a value up here, when we say y equals doubled x, this value of x gets copied down into whatever is down here below. Okay? So if I say x is 2, down here it goes, oh, I was given x, but I'm going to copy it into my own local copy. And input down here is going to be equal to 2. And then we just say something like int I equals input times 2, return I. Who's with me so far? We're going to go into this in more detail. Okay? So here's what happens. If we start running something in main, we start from int main. It says x is 2, y is 0. And then it says y is doubled x. And it goes, aha, doubled. I saw something about doubled before. I know it's defined down here. You gave me this value x, but just for my own internal bookkeeping, says the doubled function, I'm going to copy the value from x and put it into this own variable input. Okay, the parameter input. And now I'm going to do this calculation. We have int I equals input times 2. And what was input? Input was a copy of the value that was in x. And that what value did x have? So 2 got copied from x into input. Input's 2. What's 2 times 2? 4 for correct values of 2. And then we say return I. So I is now 4 and we return I. What this return does is it says where you saw this doubled x right there, make that whole value doubled x equal to whatever is returned using the return statement. So that whole thing becomes equal to 4. All right. Everybody with me so far? Should we run this and see if it works just for fun? It's always safer that way. Worried for that. Took a little while. Okay. It would help if we output something, wouldn't it? What do you think? Then we'd know what was going on. So down here, let's see out. Y was Y. All right. So here's our algorithm, right? Our main algorithm is take a number, double it, set y equal to that double number, and output what y was. And our sub-algorithm down here says, when somebody gives you a number, copy it into this thing named input. Take an int I, set I equal to input times 2, and then return that calculated value. And when we return, that means the whole thing right here, this function, becomes equal to what is returned. Uh-oh, yes?
I'm just wondering like in what order you read. Like,
We'll get into that, yeah.
as far as like input, could it have been anything or?
Yep, this right here doesn't have to be input. I was using that to show you conceptually that that is the input into the function. This parameter name input can be any legitimate C++ variable name. Yes? It is declared right here as part of the declaration. It doesn't have to be declared separately. This right here, where we put the parameter list, is its declaration, effectively. So, yes?
Is it because that in the first part of the regular parameter y equals double x that you can then down there write double int?
So right here, doubled, we're essentially defining our own command, right? And there's two steps to defining our own command. There's using the prototype, which just shows what type it takes and what type it returns, okay? And then there's the actual definition of what it does, all right? And the reason we're able to say doubled is because down here we wrote as our sub-algorithm for doubling things that we named, and we said this is exactly what it does. Take a variable, set it equal to whatever we were given by 2, and then return that variable. Does that kind of answer your question? All right, other questions? Going once? All right, so I actually didn't run this to our satisfaction to prove that it worked because I had forgotten the output. So let's actually prove this works. If it works, it will print out y was 4. Oh. Oops. All right. Everybody with me so far? Yes? Any questions? All right, so let's write another function. Let's write a function that triples things. Who wants to talk me through tripling things? Come on, I know you want to. Go ahead.
Well, you can change the name.
Nope, we're going to keep doubled because doubled is separate than tripled. Let's do something new.
So you would make a prototype for it and
Uh-huh.
call it int triple.
Yeah, we make the prototype first. The prototype has the parameter list, which is the input to the function, the return value, which is the output, and its name, the identifier. Okay, now what?
Then after your definition of double,
Mm-hmm.
you'll make definition of triple, so int triple, and int like some other variable name.
Okay, so tripled int some other variable name. I think we're going to get tired of typing that, but I'm happy to go with it for your case, for sake. Okay, then what?
Then you could have int y, or wait, y.
Okay, so here's the thing. We did use y, but we can use it again, okay? Okay, so notice here that we had y up in main, right? We had y up in main, but we also had y down in tripled. How many of y'all think that's going to cause a problem? Anybody suspect it's going to cause a problem? How many of y'all worry? How many of you would be a little bit worried it might cause a problem? But you don't. How many of you just don't know if it's going to cause a problem? That would be the right answer. So here's the deal. These variables that we talk about only exist, they only exist between the curly brackets where they are defined. So this int y only exists in main. We can reuse y down here in tripled because it only exists essentially in the parameter list in between the curly brackets. So it's not, this copy of y is different than the other y. Yes?
Why wouldn't you want to just keep them the same though? Like why would you have y above and then have I? Like did you just do that arbitrarily?
I just did that arbitrarily, and the reason I used I instead of y or something, and this was not to confuse you with the idea that you can have variables in different functions that have the same name. But since my willing participant from the audience suggested y, I just used it again so you could see that you could reuse it. Okay?
So it would
Well, let me just point out one thing. Y is a horrible variable name. Unless we're working on our Cartesian plane with an XY plane, that's the only thing I can think of where Y would be a good variable name. Most of the time you want your variable names to be more informative. When I write my programs, and we'll see this if you look at my code sometimes, you will see that I reuse the same variable names is just to help understanding, right? So if I'm passing in a particular thing like number of legs a mammal has, I might use the variable mammal legs, and then I'll use mammal legs elsewhere as well. But for example, for this, I'm just trying to show you kind of how it works. Yes, sir? No, it's not. What ends up happening is each one of these functions gets its own chunk of memory to work with, and within that chunk of memory, they get their own variable names. Does that sort of make sense? That's like the high-level wizard the explanation. But so you can reuse variable names between functions, and for the most part, it won't cause any problems. Yes?
Like when you're doing functions like this and you're defining them, would it be bad to use the same variable each time you define it? Like
No, it would not be bad. It would be fine to do that. Absolutely fine. I just used I because it wasn't X or Y, and I use I a lot. Mostly when I use the letter I, it's for a loop. Like when I have a for loop, I use I as just a default thing. And if I have for loops inside of each other, I'll use J, K, and L after that, depending on how many loops I have inside each other. So for me, that just means it's a loop variable. And if I look at it, it's a loop variable. And so I just used it this time for no particular reason. So, all right. So now if we want to trip, so everybody, other questions? Other questions about functions? Yes?
So in the triple part you use Y, but in the after int main you also use Y and
Yeah.
something else?
Yeah.
But that's doing a double thing?
So I used Y in tripled right here, and I used Y up here in main. And the point of doing this was to show you that variables inside functions, and main, by the way, is a function, variables inside functions only exist inside that function by name. So you can reuse names between different functions, and each function gets its own essentially set of names to use, right? So if you use Y in main, it's different than Y in tripled. It would be different than Y that was in doubled. Nope. There is no connection between int main and tripled. Right now, there is no connection at all, right? Here's int main. Does int main refer to tripled in any way at all? It doesn't. There is no connection between the two of them. The only connections that happen are these connections right here when the function is called. So there's a connection between doubled and main because main calls doubled, and the connection of data is that it inputs, when you call this sub algorithm, it inputs the value from x into this variable input right here. It copies it over. Okay? So what happens is the way you can think about this is that each, and I'll show you some exceptions to this later because it's not universally true, but the way to start thinking about it is each one of these things is its own sub-algorithm. We've been working on programs. Our programs take input. They take input from the keyboard or from file, and they produce output. And right now, all our output has been to the screen. What we're doing with these functions now is that our functions are essentially internal things. They take input in the form of parameters. The parameters get passed in, and they have output in the form of return values that gives data back to where they were used. Does that kind of make sense? So who wants to be my tripled function? Anybody? 7. Okay. Who else wants to be a tripled function? 9. 27. Okay, so the input is the parameter list, and the output of this subfunction is the return value. Does that make sense? Everybody good with that? How many of y'all happy with that? Okay. This class, the class seems unhappy today, so it's probably because they don't have candy. All right, now if we want to, now let's just compile this really fast and make sure it's working. We'll compile it. We didn't make any mistakes. So now that we've defined this function, tripled, we can also use it elsewhere, okay? So let's try this. Y is equal to tripled of Y. C out y. Okay? So here's our main function. X is 2, y is equal to 0. We set y equal to doubled of x. What is x? What is doubled of x? So it prints out 4. We print out y is equal to 4. Now we set y equal to tripled of y. What is y? So the value 4 gets copied down into some other variable name down here. So what is some other variable name now? And so y, this different y is 0. This different y becomes equal to 4 times 3, which is 12. Now we turn y. So this whole thing up here tripled. This whole value, remember everything in C++ can be expressed as a type and a value? This whole thing gets replaced by an integer value of 12. And the y here in main then becomes, and it prints out 12. So we should see now, that if we compile it and run it, we get 4 and 12. What happened? Oh, it would help if I saved it before I compiled it. 4 and 12. Yes?
Could you, like, say we wanted to make a function that was like times 6?
Sure.
We had 2 times 2 and times 3. Could we just like define it in terms of the other two functions?
Yes. Okay. So here is the question. The question is, say we wanted to do something that was called times 6. Let's just go ahead and do this. Int sextupled. Is that right? Sextupled is something that's multiplied how many times? 6 times. And so we've created our function, and down here we want to create something that is int sextupled, which is really hard to write, and I'm kind of scared doing it in case I have a typo. And we take some int, what do you want to call this? Int cow. Thank you for not saying some other variable name again. All right, and in here, the question is, can we use our prior functions in order to make it sextupled? And the answer is, okay, how do we do that? Okay. Does this seem crazy to you? How many of this seems crazy? Well, this is not crazy. This makes perfect sense to me. All right, so here's what we're doing. We want to sextuple something. So if we triple it, we get 3 times what it is. And then if we double that, we get 6 times what it is. How many of y'all think when we compile this is not going to work? Anybody think this is not going to work? My giveaway should have been that it made sense to me. So if we go back up here now, to main, and we call can't spell that sex. Okay, so first y will be doubled of 2, which is 4. Next it'll be tripled of 12, which will tripled of 4, which is 12. Next it'll be sextupled of 12, which will be 72, hopefully, if it all worked. Let's go see if it worked or not. Compiled correctly. We run it. 4, 12, 72. So I was about to do a different example, but the question of can we combine these things is absolutely. You can call functions from within other functions. And in fact, what happens here is the computer looks, and you remember precedence? How do precedence rules go? What's the first thing that gets calculated? Functions, parentheses, right? It's actually parentheses first. So what ends up happening is we go, oh, inside these parentheses we have a function, and we have to triple cow. So we get 4 in, and what, wait, do we get 12 in? Right, we get 12 in for that. What's triple to 12? 36. So this whole thing right here gets replaced with 36, which is then sent to doubled. And then what happens? And then we get doubled and we get 72. All right, everybody with me so far? How many of y'all think you're with me? Who's against me? Take a 1-minute break, stand up in place, stretch. Think of questions. What? Yeah, composition of functions. It's sort of like that, yeah. The heck? Yeah, so the question is, if for the last project, could we have made a function that, given all the things in the file, does the computation and tells you how much water? You absolutely could have. Yep. Yes, it would have been prettier. So one of the things about functions is that we use them to clarify what we're doing, right? You can look at a series of steps and figure out what they're doing, but if they're encapsulated in a function and the function name is compute amount of water available at camp, then somebody who's reading your code can say, oh, look, this line computes the amount of water available at camp. Does that make sense? Instead of going, oh, it does all this math and figuring out what the math does. And then if they want to know actually how you do that computation, they actually go look at the function to see how it works. So int main is a special type of function. It's a very special function that the computer knows is the first function to run. Okay. Now hang on a sec. I figured I was going to run out of batteries today, and I want to change my little battery pack here. Okay. Yay! Now we won't lose the recording. Okay. So yes, you can clean up your code quite a lot, and most code that you read, people will use functions. It just makes it a lot easier. The other thing about functions, and I'll tell you this, is it makes your code a lot easier to test, right? Because what you can do is you can break your code down into all the functions you're going to do, and then write test where you just test each function to make sure it's working correctly. And then once you know the function's working correctly, you combine it with other things. And the nice thing about it is that, we're working by ourselves in this class, but when you're working on a big team, you can come up with the design of all the functions and hand out functions to people, and everybody can work on the functions all at the same time, and then when they're working, you bring them back together. So. It is possible to put parameters in int main, but we're not going to cover that in this class. So. All right. Sir? Yes, you can, and we'll get to that in a second. We'll talk more about that. I'm just trying to get you to understand that for a function, it has inputs, which are, why don't you all say parameters? Inputs are, parameters are, come on, inputs are, parameters are, return values are. That's right, okay. All right, so that's what I just want to say, and we'll talk more about what you can do with parameters, and you can have 0 or more parameters. You can have things that don't actually return stuff, but we'll get to that later, okay? Yes? Uh-huh. Yeah, so, in fact, if I wanted to, I'll just show you. I wrote this out in kind of a long form for you so that you would understand, but here's what we could do if we wanted. Okay, so what I did is I got rid of f entirely, and I just say, hey, compute triplet of cow, double that, and then return what you get. You don't even have to put it inside a variable. But that's prettier. That's the way I would have written it if I weren't teaching you what was going on. Okay, but I'm just trying to break it down and make it much more much more explicit about what's going on. Does that make sense? So that you can kind of see what's going on. I'm doing my best here. I don't want to make the code too dense and do everything in one step, because if I do it all in one step and there's like 5 things going on, you're going to be like, ah. Whereas if I can do it this way, at least that's what I hope. Yes? No, I could do it on all the other ones as well. Yeah. Yeah. Yeah, let's just pretend I didn't answer that question. Okay. We'll just do it this way right now, and as we go on, I'll show you a more compact notation. Okay. You can think of this as like a contraction. I cannot attend the meeting today. I can't make it. Right? One, they mean the same thing, but one is a little bit more concise way of saying it. It's just that I'm trying not to be too concise, because sometimes when I'm too concise, I confuse you. It happens, and then instead I confuse you about why I'm being concise. So I have to choose what to confuse you about. So. All right. Everybody kind of see how this happens here? What I would like to do, what I would very much like to do, is I want to go through this once, and I want to trace it like we were tracing code, like I showed you the other day, so that when you have problems on the exam, you kind of have a sense of how to deal with the fact that it's not one just straight line anymore. Okay, we're going to be kind of jumping around all over the place. So what I'm going to do, if I can not screw it up, is I'm going to add these line numbers back in. You can see them here on the side. And we're going to start stepping through the code to see what happens. Okay? And over here in this window, I'm going to try and show you what the different variables are at different times. Okay? So, here we go. Where do we start? We start our trace at int main, so we really start at line 10. And do we have any variables at line 10? Nope. We get to line 11, it's blank. We get to line 12, and what happens at line 12? We get a variable x, and I'm going to make a couple more spaces there. And at line 12, x becomes 2. So I put that line in there twice, just so that x shows up as our header and we know what variable we're talking about. Okay. Then we go on to what line? 13. At line 13, did anything change with x? Still 2. And we have another variable, which is y, which is what value? 0. And I'll just add to my header line up here that we have y. Okay? Everybody with me so far what I'm doing? This is exactly what you need to do on the exam. Okay, line 14, nothing happens. We get to line 15 and something weird happens. We go to 15 and we say y is equal to doubled of x, right? So here's what I like to do. I just write jump, because we are jumping to another point in the code. And where are we jumping to? We got to find where this doubled function is. So we go down through here and we go, oh, here's doubled. We jump to 29. And down to here, I go, okay, now I'm at 29. Line 29. And at 29, what happens? We get a variable named input at 29. So I say input. Oops, wait, what happened? So we jump down to line 29. Sorry, I typed into the wrong window and confused everything. Okay, so down here, we get a variable named input. We used to have, in this part, this is where we are in main. And this down here, we are in a part called doubled. Okay? Now, what value does input have? Why does input have the value 2? Because up here, at line 15, we call double with the value x. And this value x gets copied into the parameter input down here. There it is, copied in. So we copied this 2 from x down to input. Okay? Everybody with me? Everybody good on this? You see how we're kind of jumping around here? It's important. All right, so now we've done line 29. There's nothing on line 30. Nothing on line 30. And then line 31, something interesting happens, which is we get another variable. What's its name? It's named I. Does anything change for input? Input is still 2. Let's go up and add a header for I. And what value does I have? Nope. Oh, sorry, I accidentally typed over input here. Sorry. This dual screen thing leads to problems when I accidentally type in the wrong window. Okay. So we don't have an initial value for it, so I'm just putting a question mark there. We don't know what it is. Everybody with me on this? Great. Go on to line 32, and now what happens? 32, I becomes equal to input times 2. Input is what? So I becomes 4, right? All right, line 33, nothing happens. Line 34, what we do is we return what value? 4. All right, now we go back to main. I always call this pop. I call it jump or pop. And we essentially pop back to main. So here we are back in main. And when we get back to main, we are still on line 15. And we still have these variables x and y. Except now at line 15, these variables might have changed value. Okay? We're back at 15, and we know that y is equal to doubled x, and we just computed y because we computed what doubled x was. Doubled x returned what? And so where does that 4 go? Into y. And what happened to x? Still 2, and now y is 4. Everybody see what happened there? Everybody understand through these steps of line numbers how we jumped down to the doubled function, did some computation, and came back here. Everybody see that? You be able to do this on the exam? Yes? How many of y'all are able to do it right now? I have 6 practice problems for this class and the next. So, questions? Yep. So so this I should take that 12 out. I just copied that over to keep the headers, so I could keep track of what variables were. And I can take this out too. Sorry. But I just use these to keep track of which variables are in which column. Does that make sense? Oh, from in main? Sure. So here's what happened. We started at main. Nothing happened. At line 12, we declared a variable x, and it became 2, right? There's line 12 right here. We said x equal to 2, and so over here we wrote 2 in the x column. At line 13, we had y equal to 0, so we added a y column and set y equal to 0 there. And then we got to line 15, and we said, aha, we have to call this doubled function right here, right? At line 15, we call the doubled function. If you look to see where doubled was, it's down here on line 29. So that's why I said jump to 29. And I put a little notation doubled here so that you'd later when you reviewed this would see where we were. And at line 25, line 29, we actually declared this variable input, and input got the value copied from x into it. So we now have input, and it has a value of 2. Does that help? Yep. Yes, so what happened is doubled, remember, doubled has its own space for keeping track of variables, right? It just has its own space. So it does all the calculations, and it returns 4. What happened is this whole declaration, this whole call to the, sorry, not a declaration, a call, the whole call to this doubled function on line 15 gets replaced with whatever value we computed here, which was 4. And when I say pop, that means go back to where the last jump was from. Does that make sense? Everybody with me? All right. So back here, now at line 15, y becomes 4 because that's what was returned as a part of that call. Everybody with me so far? All right. Should we do the same thing for tripled really fast? Run through this. So then what happens is nothing at line 16. Line 17, x is still 2, y is still 4, but what we have is like output to screen. And what I do over here is I say it outputs y was colon 4. Right? And this is how I keep track of my output. Right? So that's line 17. Now we get down to line 18, nothing happens. At line 19, what happens? We have to jump to the tripled function. And where's the tripled function? It's at line 37, so we say jump to 37, right? And just take that space out. Okay, now we're down here in tripled, and we start at line 37. What happens at line 37? Jesus. Okay, So we have to declare a header that has some other variable name. I'm just going to abbreviate that because it's way too long to write out. And what value gets copied into some other variable name? All right, so we called triple with y. Y up here is 4. This parameter y gets put into some other variable name down there, which is 4. Oh man, wrong window. Which is 4. So some other variable name is now 4 at line 37. At line 39, we declare another variable. What's its name? Its name is I. And what value does I have? Oh, sorry, I'm looking at doubled instead of tripled. You are correct. It's y. And notice here that this y is different than the y in main, right? Totally different than the y in main. And what value does it have? 0, because we actually initialized it. At line 40, we do some calculation, and and y becomes equal to some other variable name times 3. 4 times 3 is 12. And then this whole thing, return, and at line 41, we return 12, and we pop. And pop means go back to where the last place there was a jump, which was main 19. So now we're back in main at line 19. And we still have the same variables we had before, so I'm going to copy this header line over, trying to do this slightly neatly. Okay, and now at main, has x changed? So it's still the same as the x up here, which is 2, and has y changed? And it's now 12. All right, everybody see how we're using this line number to keep track of where the flow of control goes? Yes? Questions? Yes?
You said that this is useful, like, in the exam, but this just seems like it would take a really long time.
You can do it a lot faster writing it out with pen and pencil than I can typing it. And yes, it will take a long time. But the other choice is to take a short amount of time and to get it wrong. So you have a choice. I mean, you're going to have 75 minutes for the exam. They'll probably be on the order of, depending on what type of questions I have, 7 to 10 questions. And there'll probably be like 5 questions where you actually have to trace code. And on a midterm like this, where we're just doing function now, there will probably be 1 problem on functions. So the answer is yes, it does take time, but this is the logical, ordered way to do it. And I'm trying to teach it to you completely now so that you know how to do it completely. You don't always have to do it this completely. Sometimes you can just look at these things and go, oh, like we don't necessarily have to trace the doubled thing once we know what's going on. You look at it and you go, oh, that doubles it, so I'll just double it, right? But I'm trying to give you a clear example, even though it's simple, so that you can do it later. Yes? No. I will not give you line numbers. Why? Do you want line numbers? I might give you line numbers, but they will not necessarily be sequential. How about I just randomly order them? You write your own line numbers in. Okay. Yes? No, we don't. We could put sextupled anywhere we wanted because we use the function prototypes up ahead. And that's why we use the function prototypes. It is possible to do this without function prototypes, and you put all the functions before main, but then you have to make sure you have them in the right order if they call each other. And it's actually physically possible to have function that calls a function that calls a function, like in a cycle or a loop, and then it is actually physically impossible for you to order them in a way that'll make sense, which is actually one of the reasons why function prototypes exist. So, but that ends up being more advanced. So, yeah. Nope. It doesn't matter what order you put them in as long as they're defined somewhere. The compiler will find them. So the order where they get put in the file doesn't matter. In fact, we don't have to have main at the top. I just encourage it for this class because it's easier for us when we're reading your code to start reading from main instead of looking through a whole list of stuff trying to figure out where it is. Right? Uh-huh. Yeah. Sure. You want to put it before doubled and tripled? All right. So it's going to throw all our line numbers off for other example. So I'll put it back in a second. All right, so sextupled comes first, still compiles, still runs. And what makes that possible is those function prototypes. So, nope. There is no order. Once you use the as long as the prototypes appear before any of the function definitions, you're fine. So, and what ends up happening in like the real world in big programs is something different than I want to get into. Yes, questions? Yeah, this is showing your work. This gives you partial credit, right? Like say right down here, you're like, oh yeah, 4 times 3 is 16, right? And you think it won't happen, but it does, right? People just they get busy, they get stressed, and they're running out of time, and they just put the wrong number down, right? If you just wrote that it output 16, I would be like, that's wrong. But if you do that, I look and I go, you knew what was going on, you just made a math error. I'll take a small deduction off for that, but not as much as if you're thinking we're opaque. Okay. All right. Everybody happy with functions so far? Everybody good? All right. I'm not going to step all the way through what sextupled does, but essentially what sextupled does is somewhere in the middle you say, oh, sextupled jumps to doubled and then doubled jumps to tripled, or vice versa, right? You have to put those all together. Normally I do it from the inside out, so I would say, oh, it jumps to tripled and then that returns to doubled. All right, but everybody kind of see how we're doing this flow, this control flow? This will help you. This is actually the first semester I've explicitly taught this in such detail. And the reason I've done it is because I had a bunch of people in the past who I thought were doing well and did poorly on the exam, and I realized just last year that I was not doing a good job teaching the skills that you needed to do the problems on the exam. I was teaching all the skills you needed to program, which is similar but disjoint. You need to know how to do this for the exam. Okay. So you are my experimental class. I expect exam scores to be higher than they have been in the past. And if they are not, future classes will suffer because I will not do this again. I'll keep doing it. It is my fault for not doing it in the past. I probably just wasn't doing that good a job. Questions? Yes? Okay, so the question is, why would you use a function as opposed to calculations? And here's the answer why. Let's say that our calculations took up a lot of effort. Like so far for our class, our calculations have been relatively small, right? But let's say that we had some list of functions that was relatively large, like hundreds or thousands of instructions. And what was happening is at different points in the program, and different points in our program, we had to make the same calculation. What would happen is if in that program, like you were making calculations one place and you're making them some other place, you would have to cut and paste those thousands of lines of code right in there. And then what ends up happening is it makes your code hard to read. But the particularly dangerous thing about cutting and pasting the same thing is you might be testing your program and discover a bug over here and fix it in the first copy and forget to fix it in the other copy. And then it becomes a nightmare. So I know people who will go out of their way to write additional functions just so that they never have to cut and paste code. Like if the same thing happens twice, they make a function out of it. And their code ends up having a lot more functions than mine might. I'm kind of lazy, right? I'll be like, I'll just do this. Yeah. It's only a few lines, but they will never do it. So. No, functions are awesome. Yeah, anyway, I could go off on a whole diatribe about functions, but they're awesome. So for which project for last year? So project 1 last year, the computations were really much harder. Like I said, I was a little bit harsher on the fall class than I was on this class because we had all the incoming people who I knew were going to be majors in. And so I wanted to tough them up a little bit. So doesn't mean you're going to learn anything different. It just means that I don't know how many are going to be majors, and so I don't feel compelled to have you excel to the same level, right? It would be like if if this was like a beginning running class and I wanted the fall semester to be ready for the Olympics, and I just wanted to have you to have fun and learn a lot. Maybe that's a bad analogy. So it's like you come into basic training and the fall people have to go to the Navy SEALs and you are just going to be regular. Yeah, Lion Army, right? Something like that. So, I was a little bit tougher on them. You're learning the same things, but I pushed them a little bit more. And at the end of the semester, I told them that, and you should have seen. I wish what I need is like a camera on my computer that can record face expressions, because sometimes I say things and I didn't even know what face they made. They're just like, really? So, anyway, I'll be honest with you. My teaching evaluations are better the harder I make the course, though. So I expect you all to give me worse teaching evaluations than them because I'm making it easier on you. It's true. It's the way it seems to work. So, I don't know. Maybe I'll crank up the. Do you want it harder? Okay. All right. Other questions? Anything? All right. So I want to show you a couple of other things. Let's see where I am. So let's just go back to this. So the question was, can we have functions that don't take parameters? And the answer is absolutely. There are some functions that don't take parameters. So we could do something like we could have a function and we could name it always return to. Now, and the idea of this function, what do you think this function is going to do? There you go. Now, why would you, oh, wait a minute. Why would you do that? You wouldn't do it. Like, there are times where you have functions that don't take any parameters. There's plenty of them. But always return to is a bad example because we can just use to or a const or something like that. Let me think of another one. So we could say like a good, okay. So this one doesn't make much sense, okay? Because we have to. But let's say we wanted to have a function that was something called print instructions. Okay? So we're going to have a function, and the whole point of this function is just to print some instructions out, right? And I'm doing this a little bit wrong on purpose. Thank you. Okay, so we just want to print some instructions, and the instructions for this are just to run the program. What input does this need? Nothing, right? So we leave the parameter list empty. But here's the other question. What output does this produce? What does this give back to the place where it was called from? Does it give anything back? It doesn't. We're not doing any computations. We're not doing anything. There is a special type for this, and it's called void. When you have a function that does not need to pass the results of any calculation back to where it was called from, you can use void. So always return to, that dumb function that always returns to, shows you that not all functions need an input to have an output coming back, but you also have functions that don't return any value that you need. They just don't. They just do something and they don't have to pass any value back to where they came from. Okay? All right, everybody with me so far? So void is a special type, and void is the special type that means no type. It does not have a type because it is not returning anything. All right, so let me compile this and show you that these two things work, because I hope they work unless I made a mistake. They do. And we're not using them, so we're not going to see any output, but it does return. If you try and give a parameter to something that doesn't need one, the compiler will complain. If you try and return a value from something that has a void value, like if we try and return 3 from print instructions, the compiler should complain. It'll say, hey, print instructions is void and it's trying to return something. But if you want it to return anyway, you just put return in there with no value and it will like that because you're not returning anything. Okay. Oops, sorry. So if you do not put a return at the end of your function, the compiler will automatically put a return with nothing in it at the end for you automatically. Okay, so we have functions. Functions take input in the form of functions take input in the form of, and they have output in the form of return values. They can also output to the screen using cout. They can do anything we've seen. Do all functions take input? Do all functions produce output? No, they don't. If they are not producing output, what type do they have? And if they do not take input, what is in that parameter list? You still need the parentheses there, though. Let me make this clear. You still absolutely need the parentheses because the parentheses are what show the compiler that this is a function rather than a variable. Does that make sense? So we could have a variable that was named int always return 2, but the fact that there are parentheses there mean that that is a function. You absolutely have to have the parentheses. Sir?
Why is int main not a void? Why did it
So the question is, why is int main not a void? I will show you why. Because the language specifications say that main must return an int. C++ requires it. And what this return value is used for in C++ is an error code to say whether the program ran correctly or not. Most often. It can mean other things, but most often the main function returns an error code. 0 meaning there was no error, any other value indicating that there was an error. Yep. There is a way to pass parameters into main inside this so that when the operating system stuff happens, it dumps a whole bunch of stuff into main that main can parse as parameters. We will not cover that in this class. But it looks something like this. Yeah. Yeah, I didn't want to type it all out. But yeah, you can put some other stuff in there. It can. We're not going to do it in this class. Other questions? No? Nothing? Great. Let's do a practice problem. There's two. There's function 1 and function 2. I want you to step through, do the line number stuff. It should be pretty easy. We'll do one, then we'll do the other. And you know what? I'm just doing this because you have to take the exam early. So I want you to make sure you get some practice too. Other people have to take the exam early too. And I think I handed out too many copies. Sorry. Others are talking about some. Pass some over this way because I handed that side of the room too many. Question? No, the answers for the practice midterm are not posted. They will not be posted. You have a computer, type the code and run it. You have the Oracle sitting on your lap that will tell you what the answers are. I'm not going to tell you what they are. Just type it in. You know how to compile and run things. All right. Any more? There should be at least one copy. Pass it this way. Can you pass it over? Pass it over. Pass it over. Pass it over. Nope. As long as your numbering is consistent, you can number your lines anyway. My editor numbers the blank lines, but you don't have to number the blank lines on your sheet if you don't want to. It's really for your use to show your work, okay? Okay, who's ready to talk us through function 1? Function 1. What does function 1 output? Yes, sir. 8 space 512. Does that seem right? Everybody agree with that? Okay, why? Okay, so stepping through the program, we create int x equals 8. We create int y equals 0. Y equals cubed of x, so we jump down to the cube function. The value from x is copied into the parameter now named z. Z is equal to, then we just return z times z times z, which is 8 times 8, which is 64, times 8, which is 256. So we return 256, and because of the equal sign, 8 times 8, 512, sorry. Because of the equal sign, 512 gets copied from the cubed of x, which has become 512, into y. Then we see out x, which is 8, and y, which is 512, and we return 0. Everybody good? All right, have you all done function 2 already? Why don't you go on to that one if you haven't. All right, who's ready to talk us through function 2? Function 2. You two answer all the questions. How about someone else? Go ahead. Uh-huh. Okay, so the answer is outputs 8 and 0, and your explanation was correct. I'm going to say it again into the microphone so it gets recorded onto the video, so if you want to go back and look at it, we'll see it. But here's what's happened. We declare, inside main, we declare an integer variable x, named with a value of 8. We declare y that has a value of 0. We call cubed of x. That value 8 and x gets copied over to the z and int, the int z in cubed. It calculates 8 times 8 times 8, which is 512, and returns that. The whole thing in main that says cubed parentheses x gets replaced with 512. But because there is no equal sign, that value is computed, but it is never stored anywhere. It is just gone. So the next line at cout, it outputs 8 and 0 because no assignment was used. Questions? Yes, sir. Great. That's fine. Yeah. I'm teaching you how to go through and get the answer so that you have a logical process to how to approach these problems. If you just wrote down the answer and it was correct, you would get your correct points. The questions on the exam will be harder than this. You will have time to do this for everyone as long as you're reasonably proficient at it and you know what all the commands and stuff do. So.